Hello everyone. So today we are going to solve 21 of August gigs for gigs problem, that is transform string. But that problem is saying is we have given two strings S1 and S2. We have to find the minimum number of steps required to transform the string S1 to S2. What is the steps meaning here is we can we are only allowed to do operation or transformation from string S1 to S2. We can pick any character from S1 and we can append that character to the beginning of the string S1. We can do any number of times, but we have to find a minimum number of these transformations required so that we can make the string S1 as equals to the S2. The point here is if the transformation is not possible at all, then we have to return -1. Otherwise, we have to return the minimum number of the transformations required. So let's go to the whiteboard and see how it is going to be. So consider we have this string gigs for gigs and 4 gigs. So what is the important part is first start from the beginner level. We have to transform the string S1 to S2. Okay. So and we have to do like transformation, and in transformation what we can do is we can pick any character from S1 and we can move that character to the beginning of the string S1. But the important point is, will the length of the string will change? No, it will not change, right? S1 length will remain same as it is, as it was before, even if you append character at the beginning or ending or anywhere. Same for the S2. Like we are not going to change anything in the S2 because we have to make the string S2. Okay, we are going to only change in the string S1. So in that case, we can just write as a base case. First base case is if length of S1 is not equal to S2, then there is no transformation possible, right? Then in that case, we simply just return the -1. There is no possibility to do any transformation. Second thing is like consider if their length are equal. Okay, S1 and S2 length are equal. Consider this example A, B, and D, and consider something B, C, D. Their length are equal, this 3 and 3. But the here point is we are allowed to move any character from any place to the beginning. Can we anyhow we will make C? No, we cannot make, right? D can be make because D is D possible. B can be make. Can we make C? No, we cannot make. Okay, so it means frequency of the character that are present in the S1 and frequency of the character that are present in S2 should be same. Okay, what I mean from here is consider frequency of this like this will be A1, B is present one time, D is present one time. This is the frequency of character present in the S1. What about S2? S2 we have B is 1, okay, C is 1, we have D is 1. Okay. So if A is 1, can A is matching in this? No, A is not there. So anytime you can do transformation, any number of transformation you can do, you will not be able to get A, right? So there is no point to go further. Like it will just simply say if the frequency of the character not match, we cannot do any transformation and we will just return the -1 in that case. Now the third case is consider we came to the this problem consider their length is same, their frequency is also same. Okay, but then now how many number of operations required to do that? Now in that case there is no -1 case would be possible, right? If the length of the strings are matching, if the number of characters are matching, their frequencies are matching, it means there should be some minimum number of transformations are there that we can use to make the S1 as the S2, right? So it means answer would be coming from here only. Now come to this third case. Consider this example only, gigs for gigs and 4 gigs. Okay, we will check from the end, how these characters are matching. Why we are checking from end, not from the beginning? Why? Because every character that we are taking it up, we are appending at the beginning. So it's better to, because the last characters are going to be unchanged. So we will start from here. Compare S with S. These are equals. So we don't need to bother about anything. We will just move further. K and K are matching. Yes, they are matching. E and E, G, these all are matching. These all are matching. What about S? Here S is there, here R is there. Are they matching? No. It means we have to move R to the front. We have to move. So consider I am moving R to the front and this will become something like this. Okay. Now I move further. I came to O. Is O is matching? No. Same O I moved. F I moved. Okay. And similarly now S is came and now this gigs and gigs completely is matching. Now we need to check its FOR is matching, FOR is matching because the frequency is matched. We have already taken care of the frequency and characters. So it means these characters are matching and we have to nothing to bother about what are there. So we will just return the okay, the number of operations required are three because three characters we require to move to the beginning of the string. Okay. Consider the other example like I have one more that will be better to understand. It will look like. So consider this example, this one and this one. Okay. Let's see. Same example. Okay. I'm starting from here. S2. Length are same. Frequency are same for these both the strings. You can check from your end, but the frequency are same. As you can see, Y, U, Z, everything is there. And now you can see why. It's why is there? No, it's not there. It's still now. It's there. It's here. Okay. It means we need to move these characters. Okay. We need to move these characters to the beginning. So to compare this Y and Y, how we will like some guys have a confusion like how we will make sure like these characters are moving in the proper order. We don't need to bother about that. Why? Consider if this Y and Y are matching. Okay. I'm moving to X. I only bother about I need to take I want X here. Okay, from where it is coming, from how it is coming, I don't need to bother about. I just need X here. So it means one operation is required to pick it up one element from here to move it here, right? Next is U. I don't need to see anything. I will just take U. If I have U, I will take U and I will move U here. Okay. So it's just a simple algorithm. You just need to make sure what are the number of characters that are matching in your both of the string that are remains unchanged and other number of the characters that are pending that you have to changed means you have to move those characters from their position to the beginner like first and those number of the operations or transformations will be our answer. Okay, so I wrote the Java code for this. Like if you're comfortable with this you can take a reference from here. Otherwise, you can like see the approach and understood the approach and based on approach, you can write your code. So what I'm trying to do here is first length will be the same that I've explained as our base case. Like if length are not same, then we just simply return -1. Character frequencies must be same. How we will find out the character frequencies? Because these strings are I have given like S1 and S2. These are not like lowercase or uppercase. We don't we have not given anything. So I'm considering all 256 characters. If we have a given like S1 will be the lowercase and all characters will be lowercase or uppercase, we can accordingly reduce this. But anyhow, this will be the big of one operation that we are considering because of the constant operations. Okay, what we are doing to here is like I'm just incrementing the I created this frequency array and I'm incrementing the s1 dot caret of I and I'm decrementing the character of the s2 string so that if these characters frequency is matching, it means we are good. Otherwise, we have to return the -1. If you are not understood this code, please comment it out. I will make a separate video for this because this is a great example or great algorithm to how to compare both of the strings. Are they matching it or not? I also wrote the frequency map, frequency like using hash map also. If you are comfortable with hash map, you can use this algorithm also. What I'm trying to do is fill map frequency, like what it is. Like first I'm taking some one string and I'm putting their frequency in the map type of data structure where I'm storing the character and integer. Character means for every string, what are the characters are there and their frequencies. So I'm storing those and then finally, I'm comparing those both of this method, compare both map frequency. So what I'm doing here is I'm iterating over the first map. I'm taking that key and value and I'm checking if that particular key is present in my second map and the value is present that is equals to the first map value. It means we are good. Otherwise, we have to return the false. So this is also you can take this approach or you can take this approach. Whatever you are comfortable with, you can go with that. Now the third point is third case that is very useful for this code. So what is this is I'm starting from the ending indexes and I'm taking the operations initially at 0. I'm going I'm going to decrement if my index are same that it means I don't need to do anything, right? Similarly for gigs like if s is as same then I don't need to do any transformation, right? In that case I'm just reducing my both of the indexes. But if these are not equal, like this case, if R is not equal to S, what we can do in that case? It means we have to move R, right? It means we have to move R. And moving R means we are doing transformation, one operation, and we are going to do the decrement the I so that we are going to compare the further string with the J like in S2. Okay. So that's what like I'm decrementing I and I'm incrementing the operation. And finally, I'm reading the operations that we have done. So it's a like you have to understood this part but like many guys are worried about like how to do move. Like if I am moving R, then we have to make the new string S1 and then we are going to compare the S2. You can go with that, but that was a very brute force algorithm. Otherwise, you can just think of like, why do we need to bother about where it is moving? We just need to make sure like, are we are removing from here and we are moving at the beginning level. Similarly, you can try out this test case. It is very helpful. If you have still have any doubt, please comment it out or like if you like or learn something new, please like and subscribe my channel. Thank you, everyone.